So this is my team members, which is me, Shahila, Shazmira, and also Alia. This video contains the introduction of gear pumps, components, operational, principle, application, advantages and disadvantages of gear pump, and lastly the conclusion. Okay, now what is gear pump? A gear pump is a type of rotary positive displacement pump that uses the meshing of gears to pump fluid by displacement. Gear pump is known for its ability to handle high viscosity fluid and provide consistent flow because of the pressure. It is commonly used for transferring oil, fuel, paints, and other high viscosity fluid in industrial application. Gear pumps also consist of two interlocking gear, which is either internal or external depending on the size and rotation motion of gears.
Then let's move to the components of gear pump. The first one is driver gear. The driver gear is connected to the prime mover, which is the source of mechanical power. It rotates using the energy supplied by the prime mover, such as a motor or engine. This rotation drives the idle gear and initiates the pumping action of the gear pump. The second one is idle gear. The idle gear, also known as the driver gear, works in conjunction with the driver gear. It is meshed with the driver gear and rotates due to the motion transferred by it. Together, these gears create the sail and push the fluid through the pump. The third one is case. The case houses both the driver gear and the idle gear. It ensures that the gears are properly enclosed and aligned for efficient operation. The case also prevents fluid leakage and directs the flow of liquid through the pump. And the fourth one is suction side. The suction side is where the fluid enters the pump. On this side, the low pressure fluid is drawn in from the inlet section due to the vacuum created by the rotation of the gears. This is the first stage in the pumping process. Let's continue with the fifth one, which is discharge side. The discharge side is the section of the gear pump where the pressurized fluid exists. The high pressure liquid, which is compressed by the gears, flows through this section to the outlet, transporting the fluid to the desired location. And the sixth one is prime mover. The prime mover is the source of power that drives the pump. In the gear pump, it provides rotational energy to the driver gear. This could be an electric motor, an internal combustion engine, or even manual lever, depending on the application. And the last one is safety valve. The safety valve or release valve is installed on the discharge side of the pump. It is a critical component to protect the pump from the damage in case of excessive pressure buildup. When the pressure exceeds the set limit, the safety valve releases the excess pressure to maintain safe operation.
Firstly, let's see how does a gear pump work. In a gear pump, the meshing of the gear is used to pump fluid. The gears are located within the housing of the pump. One of the gears is drive gear. It is connected to the engine or drive. The second gear is the driver gear. When the gear teeth come off mesh, additional volume is formed. And when they go into mesh, this volume decreases. The area where the gear teeth come off mesh will be connected to the suction line. And the area where the gear teeth go into mesh will be connected to the discharge line. When the gear teeth come off mesh, the volume of the chamber increases and the pressure inside the chamber will become lower than atmospheric pressure. Fluid from the tank enters the pumps and fills the space between the gear teeth and the housing. As the gears rotate, the fluid flows along the perimeter to the discharge area, where the gear teeth go into mesh once again. At this point, the chamber volume decreases and the fluid is forced into the pump's discharge channel. It is important to understand that the fluid in the gear pump does not flow through the mesh. It cannot do so as the gaps in the mesh are very small. The fluid moves along the perimeter of the gears, filling the depressions between the gear teeth. Next, how does an external gear pump work? The housing of the pump contains friction bearings. These bearings have grooves to provide for the lubrication of rotating parts, as well as to direct and leads to the suction area. The bearings are fixed with gear shafts. There are seals to ensure the leak-proof separation of the suction and discharge channel. The front and back covers are bolted to the housing. The shaft sleeve and rubber rings prevent fluid from flowing out of the pump. How does an internal gear pump work? Gear pumps can have not only external but also internal gearing. Let's take a closer look at how an internal gear pump functions. The suction channel is located at the point where the gear teeth come off mesh, and the discharge channel is located at the point where they go into mesh. A crescent shape seal ensures the suction area is separated from the discharge area. Without the separator, fluid will simply keep on flowing inside the pump. When the gear teeth come off mesh, fluid fills the space between them. As the gear teeth rotate further, the fluid is delivered to the area where the gear teeth go into mesh. From there, it will be forced into the discharge channel. Internal gear pump work more smoothly than external gear pump, but they are also more expensive due to the higher complexity of their manufacturing process. And lastly, what problems can occur during gear pump operation? Bearing wear. The material of the gears is harder than that of the bearing, and so the bearing will wear out faster during operation. Bearing wear can cause increased leaks inside the housing. Shaft sleeve wear. Oil will flow out through a damaged shaft sleeve. If the seals become damaged, fluid may begin to flow from the discharge area to the suction area. This will cause a reduction in the working pressure and supply.
So this is how gear pump works.
Gear pumps are widely used in various industrial applications to transfer fluids with high viscosity. Here are some industrial applications of gear pump. First of all, gear pumps are used in agricultural industry for harvester and tractor. Forage harvester rely on gear pump to power hydraulic system that control the movement of knives, conveyors, and other components. For tractor, the pump provide the hydraulic system to control implement and ensure efficient operation. Next, gear pump are used in paint industry. Gear pump is the main component of paint production to transferring the finished paint from mixing vessels to storage tank, filling station, or packaging line. Gear pump guaranteeing a consistent flow rate regardless of paint viscosity. Other than that, gear pumps are used in food processing industry to ensure a smooth flow of food products throughout production line. Gear pumps are well suited for transferring viscous food like jams, jellies, honey, chocolate, and cooking oil. Their gentle pumping action minimize shear on these products, preserving their texture and quality. Lastly, in oil and gas industry. In this production, various chemicals are injected into the flow stream. Gear pumps are used for transferring fuel oil for powering generator and other equipment. The self-priming capability allows them to draw fuel from storage tanks regardless of the fill level.
Some of the advantages of gear pump is it can work at a constant flow rate, which is provide a steady stream of liquid at a consistent speed. Second, its design was very simple, which is have a straightforward structure. It is easy to take apart and leading to easy maintenance and reliability. Third, their ability to handle high viscosity fluid efficiently, such as oil or syrup, which can be tricky for other type of pump. Other than that, it is also compact and simple design, which is ideal to use in a limited space due to their small size. Last, these pumps are built to work well even when they are dealing with a lot of pressure, which is useful for many industrial applications. There are many advantages of this gear pump. First, their temperature is very sensitive. It may cause thermal expansion of the gear and may affect the performance of the pump. Second, this gear pump cannot handle solid material. It can damage the gear pump internal part because it is not designed to handle rough material. Other than that, this gear pump can be noisy, especially at a high speed, which might not be ideal for noise-sensitive environment. Lastly, the pulsation issues. The flow of liquid coming out of gear pump tend to be uneven, which might be not ideal for process that need steady stream.
So, in conclusion, a rotary positive displacement pump such as gear pump operates on the principle of shaping fluid between rotating gears and moving it in a controlled manner. Its gear pump was compact, efficient, and reliable rotary positive displacement pump ideal for delivering steady, pressurized flow of viscous and non-abrasive fluids. It is widely used in industry application because of its known characteristic. It is also easy to handle by human.